Okay, so I have number 36, and the directions say, determine the exact non-decimal value of the following problems. So I'm going to start with letter A, and the problem says, inverse of sine is 1/2. And to find this, we know that sine is y, and when y is 1/2, we know that this is pi over 6 because on the unit circle, it says, it shows that pi over 6 is 1/2 when it's y. Oh, and we know it's pi over 6 because sine has restrictions, and pi over 6 is found in this domain or this area. For B, we know that cosine is x, and when cosine is -1 over square root of 2, it's going to be a pi over 4. But since cosine has the restrictions on its domain and it's negative, we know it's going to be in this area, so we have to say it's 3 pi over 4. So we write that over here. For C, it says the inverse tangent is square root of 3. And to explain this, I know that it is square roots of 3 over 2 divided by 1/2. And that's going to equal square root of 3. So, tangent is y over x. So when y is square root of 3, it's going to be pi over 3. Okay, so now we have D, and this says inverse of sine is negative square roots of 3 over 2. We know that sine is y, and we know that when sine is y, in the negative area, it's going to be negative pi over 3, because square roots of 3 over 2 is pi over 3 because because it's y, and you just have to go down because it's in quadrant 4 down here. So it would be negative pi over 3. Okay, in C it says inverse cosine of 1/2. So we know that cosine is x, and this one's easy. When x is 1/2, we know that is pi over 3. Okay, for inverse tangent of -1, we know tangent is y over x. So in this one, it would be square roots of 2 over 2 over square roots of 2 over 2, and 1 has to be negative. And since tangent has the restrictions in these two quadrants, we know it's going to be in quadrant 4, so it's going to be negative pi over 4. For G, it says inverse sine is -1. Oh, and we know that sine is y, so when y is -1, that's going to be down here. But we can't go around like this to 3 pi over 2. That would be incorrect because it's not in this domain. So we have to go backwards, and it's the same as negative pi over 2. So that's your answer. Okay, so next we have H, and it says inverse cosine of 0. We know that cosine is x, so when x is 0, on here we see x is 0 up at the top, and this point is pi over 2. Okay, so next we have I, and it states the inverse tangent is 0. So we know to get 0, it has to be 0 over 1. It can't be 1 over 0 because that would be undefined. So to get 0 over 1, you have to go it would be over here because y is 0 and x is 1. And we know that this point is 0, so the answer is 0. Next we have J, which states the cosine of the inverse sine of square roots of 3 over 2 is square root of 3 over 2. So first I would start off by finding the inverse sine of square roots of 3 over 2. And we know that sine is y, so when y is square roots of 3 over 2, we know that the sine is going to be pi over 3. So then we would do the cosine of pi over 3, and we know that cosine is x, so the to get x of pi over 3, it's going to be 1/2 as stated by the unit circle. For k, we have sine. We have the sine of the inverse tangent of -1. So again, I would first start by finding the inverse tangent of -1, and we know that tangent is y over x. So I would look at this and see that it's going to be square roots of 2 over 2 over square roots of 2 over 2. And one of them has to be negative because it states -1. And we know that the -1 is going to be y because it can only be in these two quadrants. So -1 is going to be y down here. And that's going to equal -1. So we're going to put, and since it's in this quadrant, we're going to put negative pi over 4. Then I'm going to find the sine of negative pi over 4, and as we know, because the units in the unit circle, the negative pi over 4, it's going to be -1 over square root of 2. So for L, we have tangent of the inverse cosine of -1 over 2 over square roots of 2. And first, I would start off by finding the inverse tangent of -1 over square root of 2, and I know that this is going to be one of the pi over 4s because it has a square root of 2 in it. And I know since it's cosine, it has to be in these restrictions. So it can't go down, we know it has to go left. So it's going to be 3 pi over 4. So I'm going to put tangent of 3 pi over 4, and the answer to that is going to be -1. Because we have in 3 pi over 4 in this area, one of the square roots of 2 over 2 has to be negative, and that's going to be the x because it's going left. So we know it's -1 when you divide those, and when you not when you divide, but when you multiply by the reciprocal. Okay, so for m, we have the sine of the inverse cosecant of 8 over 5. So first, I'm going to start by finding the inverse cosecant of 8 over 5. The opposite of cosecant is sine, so we know that this is r, that 8 over 5 equals r over y, because the opposite is sine, which is y over r. So I'm going to make the first quadrant of a graph. I'm going to draw my right triangle, and I'm going to put r as 8, which is the hypotenuse, and y is 5. And they're asking for the sine, and we already have this written down. It's going to be the opposite of 8 over 5, so it's just going to be 5 over 8, because it's y over r, not r over y. For n, we have the tangent of the inverse sine of 12 over 13. I'm going to do the same thing. I'm going to draw the first quadrant, draw my right triangle, and we know that sine is y, so it's going to be y over r. So 12 is y, r is 13. So I'm going to put 13 here and 12 here. Then I'm going to use the Pythagorean theorem, which is 13 squared equals 12 squared plus b squared. 13 squared is 169 equals 144 plus b squared. When you subtract 144 from 169, you get 25 equals b squared. You do the square root of 25 equals b, and b equals 5. So x here is going to be 5. Now they're asking for the tangent, and we know that tangent equals y over x. So our y is 12, and our x is 5, so that's our answer. Lastly, we have O, which is the inverse cosine of the cosine of 11 pi over 6. So we're going to start off by finding the cosine of 11 pi over 6. And on the, let's pretend this is a unit circle. On the unit circle, we know that 11 pi over 6 is in this quadrant, and that cosine equals x. So x is going to be positive, so we don't need to add a negative sign. And we know that the cosine of 11 pi over 6, which is the x, is going to be square roots of 3 over 2. So then we have to find the inverse cosine of square roots of 3 over 2. And we know that cosine is x, so we just have to figure out that this is x, and that when this is x, it's going to be pi over 6. And that's our answer. Then we're finished.